Welcome, everyone. Welcome. I'll give us a couple of seconds just to get everyone into the room here. I can see we've already got a few familiar faces. Hi, Israel. Jacob, great to see you again. Good to see some familiar faces there. I will make a start. As I know, we've got a couple minutes over. We had a bit of a technical issue there, but it's good to be online now. So welcome everyone. If you haven't joined us before, you are able to message each other in the chat, let us know where you're watching from, and you can put all your questions for our speaker in the chat or into the Q&A, and we will be revisiting those at the end of the session. This is also being recorded, so if you have to leave the session, you will be sent the recording of this session as well. So no further ado, I'd like to introduce Dr. Mohamed Abdallah Ahmed Al-Ria, who is a meteorologist and researcher for early warnings at the Sudan Meteorological Authority. And today he will be presenting a topic on evaluating extreme rainfall in Sudan, leveraging satellite data and global climate models in the absence of in-situ observations. So Mohamed, would you like to begin for me?
Thank you, Kathy. Thank you for welcoming me, and thank you for having me today. First of all, my name is Mohamed Abdallah Ahmed Al-Ria from Sudan Meteorological Authority, Early Warning Unit. I am here today to present my presentation about the evaluation for extreme rainfall in Sudan, leveraging satellite data and global climate model in the absence of the in-situ observation. First of all, we have an overview and outlines for presentation of today. We contain introduction on how to utilize satellite data and climate model to predict the extreme rainfall over Sudan in the absence of in-situ observation. Also, we have the research structure and the main outcomes that we got it from this research project. And also, finally, we have some recommendation and highlighting for the future work. First of all, to introduce this session today, it's follow up to the previous session by Dr. Abu Qasim Musa in the last month, July, which he discussed the situation and conflict in Sudan and the situation of climate services, especially the early warning unit, and how the situation pre-conflict and the rescue plan and the post-war situation and the key achievement from the rescue plan and the challenges that we faced and what we achieved for them. Also, he mentioned our partner, and we would like to thank them again, like Egyptian Meteorological Authority, EMA, and EGAT Climate Prediction and Application Center, ICPAC. Also, he discussed and he mentioned the ongoing project before conflicts and the network observation and the data rescue plan. But more importantly, he mentioned in the challenge that how to continue providing the climate services during this ongoing conflict and its change. And this is the main challenge that we have to address. So the presentation of today is to try and attempt to find some solution, but it will complete by recovery of the data in the future. First, as we know, like Sudan, for those who don't know about Sudan, has faced different extreme climate events in the past and in the recent decades. For example, in the left side, we see that drought that hitting Sudan, especially the western part of Sudan, during the 1984 to 1983. And we can see how the cow and livestock did. And in the recent, or in 2014, also we can see the flooding and destroy flooding that happened in Sudan. And
sorry, Mohamed.
Yes?
Oh, sorry to interrupt. I think maybe we are stuck on your first slide. Ah, okay. We're on the overview now, I think. Is that the slide you're on? Yes?
Okay.
Perfect.
Where are you now?
We are just looking at the overview slide and now the introduction. Is that the correct one?
No.
Ah.
So, how is it now?
I will just give it a second. There may be a slight delay. What I might do for now, at least, is to just turn your video off, just to see if that maybe helps the delay between the slides. So we're on the introduction slide still.
Mm. And now it's still in production.
Currently, yes, we have. Okay, we have the slide with the different extreme climate events.
Okay, and now because I already passed.
Maybe there is just a small delay. I will just see if I can stop your video. And maybe that will solve the delay issue.
How is it? Okay, I'm back to the Sudan face different extreme climate events.
Yes. Okay.
Okay.
Perfect.
Now I move. Is it okay now?
Let me see. It hasn't moved at the moment. Are you staying on the presentation screen?
Yes.
Okay. Perhaps, oh, it suddenly moved. Okay, what I would suggest is firstly turning off your video and secondly, perhaps stop sharing and then begin sharing the correct slide again. I believe it's just a delay with the connection, perhaps. Very common issue, unfortunately, as I'm sure all of our
Yeah,
know.
it's okay. How is it now?
We're on the slide with the different extreme climate events slide.
You still?
Yes, currently. Let me see if we can stop sharing here and then. Okay, I've just stopped your sharing, so maybe reshare and we will go from there.
Okay, I stop again.
Mm-hmm.
I start resharing.
Yeah, perhaps turn off your video as well. Maybe that will help with the connection. Oh, I don't know if maybe we have lost Mohamed. I will give him a second.
I reshare it again. Could you see the start slide? Yeah, start one.
Not yet, no.
Mm.
Bear with us, everyone. It's great to see where you're all watching from in the comments. I see we have a couple of familiar names there. Good to see you all. I can't seem to stop your video, Mohamed, so maybe you may have to stop your own video and then reshare your screen, perhaps.
Okay, I stop my video.
Yeah, Jacob has just suggested in the chat that if it's not going to work this time, perhaps you could present without the slides. I think it's starting to load, so we will see how we go. Oh, I think the screen sharing has stopped, Mohamed. It's up to you if you would like to start trying to screen share again, maybe.
Can I start again? Okay.
Yeah, it started and then oh, I think maybe there's just a delay. It says you are screen sharing. We'll wait.
This is the beginning one.
We'll just wait to see. It's just loading, I think. Hi, Christina. Great to have you. Yes, I can see we're at the beginning now. So, okay, we will give it another go if you'd like to move to the slide that you got to, and we'll see how this works.
We can, no problem.
Thanks
We
for
can start
coming.
from the beginning. Yeah, maybe some people they are
Yeah, no
joining
problem.
just
No
now.
problem. If it doesn't work, I will let you know. Maybe try going to the next slide and we'll see if it moves.
Yeah, they are so lucky to attend this again. Okay, everyone. Again, my name is Mohamed Abdallah Ahmed Al from Sudan Meteorological Authority, Early Warning Unit. And my presentation today about evaluating extreme rainfall in Sudan, leveraging satellite data and global climate models in the absence of in-situ observation. And overview of this presentation, as I mentioned, for 5 minutes, introduction, and then how to utilize satellite data and global climate model to predict extreme rainfall over Sudan in the absence of in-situ observation. Also, the research structure and main outcomes will be included in this presentation, and the recommendation and future work in the final and the last of this presentation. First, as I mentioned, this session is continue and follow up to the previous session by Dr. Abu Qasim Ibrahim Musa that presented in this platform last month when he discussed the situation about the conflict in Sudan and how the Sudan Meteorological Authority tried to rescue their data and to recover the data that lost by the condition in Sudan. And he discussed more about the post-war situation, the key and the key achievement from the rescue plan and the challenges that we faced through these challenges. And also he mentioned about the partner, as I mentioned, Egyptian Meteorological Authority and Aircraft Climate Prediction Center Application of IGAT. And also he mentioned about ongoing project and gave more detail about the project before the conflict and ongoing project. And also he gave details about the observation network and the data rescue plan. And he conclude and last his presentation with the, I think the main question that we start our presentation with it, that how to continue providing services, climate services during this conflict and its change. And I think this is a big challenge, and we try all of us to answer this question or to help to get some solution to this issue. Sudan has faced different climate extremes in the past and in the present time. For example, in the 18th era, Sudan has faced a devastating drought, and in the recent, like 2014, also destroyed flood are facing different parts of Sudan and caused livestock death and more of damaging the urban plan. So the main question for presentation today is how to utilize the satellite data and global climate model to predict the extreme rainfall over Sudan in the absence of in-situ observation. Actually, this is mainly for the climate projection, and the purpose for this research to reduce the data for the climate projection and its use. And the pyramid of the data, climate data, as the basic observation, then followed by the satellite data, and then the regional climate model, and then global climate model. Observation is the basic for each data. Then followed by the satellite data. Satellite data have a good spatial resolution and spatial and temporal coverage that cover all the globe. Now, recently, most satellite cover all the globe, 24 hours. Sometime temporal resolution reach to 15 minutes. And the increase of resolution is like global climate model is the low resolution, reach to 1 degree, that is mean around 100 kilometer. Regional climate model region reached to 0.5, that means 50 kilometer, and the satellite that data resolution reached to less than 0.25 kilometer. So the research flow structure for this research, we have three data type or three data set. First, the global climate model, and the second is satellite product, and the third one is the observation data. And in our case, there is no observation data, so we have two data sets, the satellite data and global climate model, and we have to do three main steps before the evaluation for historical and future projection. First, assessment. The second, the selection for the best performance, and the third one is the bias adjustment. In terms of climate model, the first one, we select 19 model, global model. Actually, they have many, more than 30 global model for the CMAP6 especially. So we selected 19. However, for more research, we can try more and more. But in our research, we tried it 19, we try also another around 18, other 18. But this 19 model had the best performance among the others. Further analysis also, we utilize statistical analysis for evaluation, for downscaling, for ensampling, to get the model ensemble for this global model. Then we corrected against the satellite data. For satellite data, we use the statistical metric to select which one, and we selected CRIPS in this research, and we corrected the models, the global model, based on the CRIPS satellite data. Using one-time bias correction method, and then we applied the bias coefficient to adjust the historical rainfall and to get the adjusted future extreme rainfall. For the part of the observation data, we're supposed to make quality control and quality assurance, and then choose and select the valid observation. Hopefully, in the future, we can do that, and we can do that in the future. But for this, and to this step, we make the evaluation by historical and future rainfall based on the satellite data. Here we use just most of our data is open source and open software. For example, Climate Hazard Group Infrared Precipitation Registration CRIPS is the open source data, and also the Climate Global Climate Model GCMs, CMAP6, Global Model Interconversion Project Phase 6, and associated shared socioeconomic pathway SSBs, SSB1, SSB2, and SSB5, and all of them that are open source and freely available. Also, we use the open source degree analysis data, Climate Prediction Center, CPC, for calculation, and open source software, RStudio and Climate Data Package, and Climate Data Operator CDO for processing and analysis and visualizing the data. For the future purpose, we use a shared socioeconomic pathway SSBs. As I mentioned, we use SSB 1 to 5. Actually, SSB 1 is the sustainable development road, and SSB 2 the middle of the road, and SSB 5 is the taking the highway of the high road of higher consumption and higher using fossil fuel and high emission. Actually, they have SSB also have SSB 3 and SSB 4, and one is a rocky road, and the other is the road divided. And for our research, we use SSB 1 and 2 and 5 as the middle of the road, and the highway and the sustainable development scenario. Also, we use the extreme climate extreme indices that recommended by WMO and expert team, like simple rainy days and maximum 1 day precipitation, maximum 5 days, very wet days, and one total precipitation, consecutive dry days, consecutive wet days, and extreme wet days. Also, we use the McCandid test for testing the trend, and we use the Taylor skill score for the ranking and ordering the climate model. After excluding the observation data, our city structure becomes like this figure, and right and the left top, CMAP6, multi-modeling sample, and down, Philips satellite observation data. We process them, and after that, we do the statistical metric for the evaluation against each other, and downscale and apply bias correction for the historical extreme, and also apply for the future extreme in the far right of the figure. And we can see here the spatial and temporal distribution of extreme rainfall, like over Sudan, and also the future of mean rainfall over Sudan. So this is the structure that we applied, and we give the figures about our result to show how we select for example, this one for selecting and evaluating multi-modeling sample against individual model of observation. On the right panel, we can see a multi-modeling sample against individual model. We use a Taylor diagram, is a good graphical interface. Show the main three statistical error metrics: standard deviation, correlation coefficient, and root mean bias distance. We select the multi-model as the best performance from the individual models and compare it with the bias adjusted with the CRIPS and with the CBC for the comparison. And you can see here in the left side, CRIPS and adjusted multi-model ensemble, they are typically in the same place, red and black. And you can see multi-model ensemble has a good performance more than CBC client prediction center data. And that is like a unique result. Also here, example for how to represent the climate of daily rainfall over Sudan for the baseline period from 1981 to 2014. And we are both of the data multi-model ensemble and CBC, they represent well the climatology of daily rainfall, mostly daily rainfall over Sudan. For example, the peak of precipitation in August. However, CBC showed less amount of rainfall in August than the CRIPS and the multi-model ensemble. And also here we can see that ensembling model has performed well better than the CBC. However, CBC is the analysis graded data, the MME or multi-model ensemble is a global model. On the right side, we can see extreme indices time series and how it's trend. For example, the mean precipitation, you can see it's increased. Simple rainy days, consecutive dry days, consecutive wet days, total precipitation, and most of them are increased except for the maximum 5-day rainfall and the 20 millimeter precipitation. Here also the evaluation for extreme precipitation for CMAP6 multi-model ensemble during the baseline from 1981 to 2014. And we use a different statistical error, Taylor skill score at the top, mean absolute error, bias, root mean square error, correlation coefficient, standard deviation in both annual and seasonal data. That means June, July, August, September, and that is the main rainy season in Sudan. And we can see all the at the bottom, the indices in the blue color, and we can see on the left side the multi-model ensemble and adjusted multi-model ensemble, CBC and CRIPS. And we can observe that the multi-model ensemble adjusted is the more matched with the curves at the level of each indices for both annual and gauges. Here is a special distribution of extreme indices for historical period. Also, we can see the mean precipitation, simple rainy days, consecutive dry days, consecutive wet days, and maximum 5 days rainfall, and we see the extreme and very and heavy rainfall, 95 percentile and 99 percentile. And we can observe that also the similar pattern as the temporal distribution, the multimodal ensemble and adjusted multimodal ensemble are performed well better than CBC. And for the distribution, we can observe that also the extreme rainfall are distributed in the southern and eastern part of Sudan. Here example for the future 10-year rainfall based on the this is multimodal ensemble from 2015 to 2100. For the near term, mid term, and far term or long term, using the density distribution. And we can see in the black color that is the baseline for the period, and we can see the SSP1 in the red color, SSP2 in blue color, SSP5 in green color. And we can see that the mean annual precipitation is more in terms of amount for the SSB5, that means the high emission scenario, and we can see the distribution is higher in SSB2. However, the SSB1 is more close to the baseline, and we can see also during the midterm and the long term they have the same pattern. Here also example for the future change of extreme indices in Sudan based on adjusted multimodal ensemble from 2015 to 2100 for the precipitation, and all the indices. And we can observe the same thing, that the intensity or the maximum or wetting indices are for the SSB5 are more than the other scenarios, more than the SSB1 and SSB2, except for the dry indices, that mean consecutive dry day. We can see the opposite, that the SSB5 is less than the others. Here example for the trend for the indices during the future period for the SSB1 first scenario, and the second scenario and high emission scenario. And during the third scenario, SSB1, we can see there's increasing and decreasing in dry days, but there is no significant change. However, in the SSB2, it's clear that all of the indices have a significant change, increasing. The wetting indices have a significant increasing change, and the dry indices, that means consecutive dry day, also had the opposite significant decreasing change. SSB5, the high emission scenario, shows the higher amount of change in all indices. In summary, using satellite data provide better spatial coverage for monitoring the extreme rainfall due to its fine resolution than the GCM, and that's why. And this research focused mainly on annual and seasonal extreme rainfall totals, mainly because this can be used for the operational agricultural activity and its planning. Also, multimodal ensemble is more capable than individual method in simulating and observing the precipitation and associated extremes during the rainy season, that's mean June to September. Yes. And also the global climate model has acceptable skills over the southern and western part of Sudan in terms of extreme event. The trend of extreme indices showed significant increase in total precipitation, accompanied with increasing and decreasing in the wet and dry days during the historical baseline period that means from 1981 to 2040. Generally, the higher emission scenario, SSB5 8.5, showed dramatic rise, extreme, in near, mid, and the long-term or short-term alterations, both annual and seasonal scale. While the Sustainable Development Scenario, SSB1 2.6, showed an increase in near term, that means from 2021 to 2040. So our recommendation that the current study suggests avenues for future research in order to gain better understanding for extreme events and the use of GCM outcomes in different socio-economic activities. First, the simulation and projection can be improved by counting source of uncertainty in addition to uncertainties of projection and its approach. For example, model structure, parameterization, bias correction techniques, and statistical downscale approach. More work to be done to quantify subseasonal, daily, and sub-daily timescale for extreme event, and that is analyzing maybe different satellite data. Technically, the satellite-based product and reanalysis data reveal less performance in very arid areas, for example, the northern Sudan. So it is necessary to adjust them with the conventional observation. That is more important. Detection and attribution for the extreme rainfall impact on linking sectors such as the agriculture, irrigation, hydropower generation, land use, and land cover management. Finally, the most of these uncertainty can be reduced in the presence of in-situ observation, and that is affirmed then important. Thank you for your attention, and for maybe for more details about the research. Just we put a highlight about the main results that we get it, and we are welcoming for any suggestion, any contribution, any collaboration that could improve this work to be better. And I would like to quote, we still have a chance to go to the right way in the future, and together we can. But more importantly, no one left behind. And thank you for having me here, Kat. And welcome for the Q&A session.
Many thanks, Mohamed, for your presentation. I've already had one person in the chat ask for a copy of your presentation file. So if possible, I might collect that from you at the end of the session so that people can look into your presentation in more detail. Do we have any questions for Mohamed? Now is the time to ask. The question I will start off with asks, how does your research in Sudan compare with similar studies perhaps in other regions with limited observational data? And are there lessons learned that could perhaps be applied elsewhere?
Thank you, Adit. I think this is a good question, actually, because I think this research can be applied on different parts, has a similar issue in the absence of the in-situ observation. So we can utilize the best performance satellite in your area that you can use it to correct and adjust your climate model. So the main challenge will be to choose which suitable satellite data that in your area, because sometimes, for example, as I mentioned, in the desert area, some satellite data had less performance according to the reflectivity that's based in the arid as to the sand, that means the land type. So, however, you can use it and apply it in your country or in your area. So this is like general idea. You can apply it whatever, and you are welcome for more details in the future. If you need anything, I will drop my email for the possible advice or possible collaboration.
Thank you, Mohammed. That's good to know. We have a lot of individuals from different meteorological services on this session and as part of our members, and they're always interested to know how different research can be applied to their regions. So that's very good to know. Saeed asks, thanks, Dr. Mohammed, for a good presentation. Did you use other satellite data, and did you find chirps is better than other data?
Thank you, Said, for your question. Actually, yes, it's an important question. Actually, we have like pre-processing for this or pre-analysis for this research. Yes, we did some evaluation for some satellite data, and we got that our results find that Egypt is better over our area, especially for Sudan. So maybe for the other area could be, for example, TRIM or other satellite data. So it's important to know which satellite data that perform well in your area. I think this is the main thing. But in our case, yes, we did many. Actually, yes, in the previous research, we validate this satellite data against some graded data, for example, like CRU and Aero 5. And we did it against the African rainfall and against stream, and they give a good result. And the research will come out soon in the near future.
Excellent. Thank you, Mohammed. I see Mohammed has also passed his email on to myself and saying that he's interested in collaborating. So I will pass that on to you at the end, Mohammed. And Ahmed has asked, did you do a grid analysis for a certain area? Oh, have we lost you, Mohammed? Can you hear me, Mohammed? I feel like we may have lost you for a second there. I'll just give Mohammed a second. He may need to reconnect to the session. It may be an internet issue on his side. Thank you very much, everyone, for all your questions. I'm hoping we will get Mohammed back in the session so that he can answer these questions. He's just dropped out, so we will see if we can get him back in the session. In the meantime, I will just remind everyone this is being recorded, and we will send out the recording alongside the presentation file. I will ask Mohammed to share the PowerPoint with me as well. And then that way everyone can look at the presentation and the recording after the session if you've joined late. But do continue to send me your questions. I will see if I can get Mohammed back on the session. And worst case scenario, if not, I will ensure to pass all of his questions over to him. Let me see if I can get him back on this session. I think he is just joining us now. Thank you everyone for your patience. Just wait for Mohamed to join his audio, and then we will go through the questions you've kindly asked.
Sorry,
Hi.
sorry. I had
Hi, Mohamed. No problem whatsoever. We were waiting for you. We've got a lot of questions, so I didn't want to let you go that easily.
Yes, I will be here. Don't worry.
Good to know. It's great to have you back. We have some eager people in the comments who would like to ask you some more questions. Let me just find the last question I got to. I think it was the question from Ahmed, who asks if you did a grid analysis for a certain area. Oh, can you hear me okay?
Yes, again, please.
Ah, sorry. Ahmed asks, did you do a grid analysis for a certain area?
Grid analysis, you mean?
Yes, yes. Ahmed, perhaps you can elaborate a little bit.
Explain. Yes, if you can, yes.
Well, I will, in the meantime, I'll move on to a question from Israel. Great to see you again, Israel. Who says, excellent presentation and summary. Some points for clarification. Did the methodology and research allow us to know the precision or level of uncertainty in obtaining precipitation data in mountain areas versus more flat areas? And is the use of satellite images good for this analysis?
Yes, it's actually, yes, good idea. Yes, it's good to use it. For example, why I mentioned that before, you have to recognize your area, because even the satellite data, it has different performance. For example, the mountain area, or the lowland and desert area, also the land cover type also affect the performance of the satellite and its estimation for, especially for the rainfall. So we have to take care about this issue. But if you are assured that your the satellite that you use have a good performance, that will reduce a lot of uncertainty that can be even in the model. For example, if you have more satellite, your satellite is more close to the real observation, that means when you did the correction, that correction is like reduce all the uncertainty that happening or that being in the global climate model. So this is a benefit of extracting the bias coefficient and applied it to correct your data. This is a benefit from that. Also, the multi-model ensemble, also they reduce. For example, this many models that have some issue at some area. When you make multi-model ensemble, this is a hypothesis, general hypothesis that it will give you a good performance than the individual one. So try, like many members, global model, they have more than 30 models. So you can try one by one the available data that you can match which one is more matching for your area, and you will get a good result in the future. And if you have some additional issue, we can contact. No problem.
Thank you. Israel says, thank you, Dr. Mohamed. Excellent. I will go to a question from Muhammadu, who says, after you bias correct your individual CMIP6 GCMs, did you use simple arithmetic to do the MME, or did you use deep learning for MME?
Okay. Thank you, Mamadu. You can use different. For example, to use machine learning or artificial intelligence. If you use it, so it's okay. But in our case, we just use a simple statistic ensembling. Yes, we use a simple statistic ensembling. But if you utilize the AI or machine learning, it will be better. I encourage to utilize the machine learning and AI. I think this is the future, actually. This is the future in the field. We have to cope with it.
Brilliant, thank you very much. I will move to Saeed, who asks, did you take all of Sudan as an average value? Is it not better divided to divide Sudan into many zones according to their climatic features and then do the projection to those zones? Will it be better?
Thank you again, Said. Yes, it will be better. Yes, for the future. For the future, yes, this is one of our project for the future to divide Sudan for the different climate according to its climatic zone. Actually, yes. But at the first, we downscale. We try to get the main picture. Then we will go deep and deep and deep. Even during the inside the climate zone, we will classify to different subzone in the future. And a good idea. Yes. Good question, Said. Good question, Said. Thank you.
Good question, Saeed.
Yeah.
The next question we have is from Arthur, who says, thank you for sharing your interesting work, Dr. Mohamed. Just two questions, if you may indulge me, I think we will. Number one, the projections you showed us for the GCMs, are they ensemble means or actual projections for each of the selected models you used? And question two, did you manage to quantify and compare the uncertainty over SSPs and the ensemble members you used?
Yes. Okay. For the first question, yes, we use the ensemble mean for the 19 GCMs together, not for the not for one, for all of them together. Actually, we make the ensemble. And for the next question, for quantifying the compared asset, yes, we apply the bias. We apply the bias adjusting or correction. Yes, we apply it for the socioeconomic pathways. Yes, for both of them, SSB1, SSB2, and SSB5. All of them. All of them. Yes.
Thank you, Mohammed. I have another question from Yi, who says, could you provide any insights on the most recent or ongoing funded projects related to your presentation on satellite data and global climate models, specifically enhancing the capacities to produce and use climate, weather, and hydrological services, including early warning systems?
Thank you. This is a good question. I think very important to get the support, financial support or logistic support. And I think Dr. Musa in the previous session, I think he mentioned all the challenges, and we are working now voluntary actually. Actually, as he mentioned, we have missed our office, missed even our homes. So now we are working in a very tough environment. So we work voluntary from different places. Some of us from Egypt, some of us from back in Kenya and other countries. So we work voluntarily. So if we get fund, that would be better for utilizing this project and make it available for the climate services for the end user. And welcome to any project. Actually, we are welcoming. I think Dr. Abugas also mentioned all the projects that are ongoing, and we can join another project. We can.
Thank you, Mohammed. The next question I will move to, I guess, is a broader context, and it asks, in the context of climate change, how do you anticipate the frequency and intensity of extreme rainfall events in Sudan to change in the coming decades based on your findings? Oh, can you hear me, Mohammed?
Yes.
Yes. Would you like me
Okay.
to repeat the question? Is that okay?
Okay, repeat it, no problem.
No problem. I'll repeat the question for you. It says, in the context of climate change, how do you anticipate the frequency and intensity of extreme rainfall events in Sudan to change in the coming decades based on your findings?
Yeah. Yes, I heard the question well. According to the first SSB, it will be more vulnerable and more high variability for the SSB1, SSB2, and the SSB5. That means the highway. They show that like devastating or dramatic rising in the intensity of rainfall action in the recent decade. That's what happened. But the last one is the SSB1, the Sustainable Development Scenario, is less, but however, it's like more vulnerable and more variable. The variability is very high. But for the SSB2 and SSB5, they show like increasing in intensity, very increase.
Many thanks, Mohamed. Do we have any further questions? Saeed with the good questions has come back to us. How about using machine learning in such research?
Yeah, I think we received some question from Mamadou. I think Mamadou who asking this question if we analyze it, and I mentioned that yes, we didn't use it, but it's possible to use it. I encourage everyone to use it, to use the machine learning or artificial intelligence in this process. I think it will be fruitful. Actually, it will minimize the time and minimize the effort. Yes, and it will be more automated. Yes, if we utilize it, it would be better. But actually, we didn't use it in our research here.
Thank you, Mohamed. I will move to possibly the last question. I'll move to this question, and if we have any further come through, then I think we may have time for them. This question asks, are there any plans to integrate more advanced satellite technologies or new global climate models in future studies?
It's a good question. Yes. Actually, our plan to utilize more satellite and more global climate model is to we try to merge them or blending them with the observation to make a new product, especially for the Sudan, that more suitable for the Sudan. And actually, it's a part of like climate approach for Sudan. It contains all the even other parameters more than the extreme precipitation or future precipitation. Also for temperature, for extreme temperature, for heat stress, for the other indices that are related to the human life. Actually. But there's still like idea in our head. I hope we can get more fund or more suitable condition and support to execute it in the future.
Excellent, that's good to know. Thank you, Mohamed. I can't see any further questions. If I do, I will get them forwarded to you, Mohamed. But thank you very much for bearing with us through the technical difficulties. We had a lot of eager attendees who had a lot of questions to ask. So thank you for making it back to answer those.
Thank you, Kat, and thank you for everyone for having me here today. I'm so happy to be with you. And as I mentioned, Kat will drop my email maybe in the chat, or maybe everyone who had any question or explanation or contribution to our research or collaboration, maybe we can communicate through it. And thank you for you all.
Excellent. Thank you very much, Mohamed. And thank you very much, everyone. We'll see you, I believe, on the 5th of September for our next webinar. So look forward to seeing you then. Thank you.